Lesson 4.6, Congruence in Right Triangles. So in this lesson, we will be able to prove right triangles congruent using the hypotenuse-leg theorem. So what I want to do first is review what is hypotenuse and leg. So in a right triangle, the side opposite the right angle, so the side opposite the right angle is called the hypotenuse. It is the longest side of the triangle. The hypotenuse is the longest side, yep. The other two sides are called legs. So any of them, this or that, they're both legs. So you have hypotenuse and you have a leg. So the hypotenuse leg theorem basically says if the hypotenuse and the leg of a right triangle is congruent to the hypotenuse and the leg of another triangle, then the triangles are congruent. So you know how like the previous properties we learned, the congruence things we learned, like side, 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 angle, angle, and angle, angle, side, they all had three things. But HL, they have two sides that are congruent. However, the third thing that you have to prove is that it has to be a right angle. It absolutely has to be a right angle. If it's not a right angle, you cannot use hypotenuse leg. These only apply for right angles. So now, so I'm going to use my hypotenuses. BC is congruent to EF, so this side and this side, and either leg. It can be any one of the pairs. So you have BA congruent to ED, then triangle ABC is congruent to triangle A goes with D, B goes with E, F. Again, remember, it has to be a right triangle. I cannot stress that enough. So let's try this. So a triangle LMP and triangle MNP are right triangles. So it's given to us. And it's already marked up for us here too. So again, if you want, you can mark it up here as well. ML is congruent to MN. So this side is congruent to that side. And that's also given to us. The next line tells me MP is congruent to MP. So this side is congruent to itself. When something is congruent to itself, it's going to be reflexive property. So now you have a right triangle. So again, anytime I have a right triangle, I'm going to first check for HL before I do anything else. So it has a right triangle, hypotenuses are congruent, and I have one leg that's congruent. So that's going to be hypotenuse leg. Let's try the next example. So again, this is a blank one. So triangle WVX and triangle YZX are right triangle. That's given, and I'm just going to label it. So WVX is that angle, and Y is this angle. Then I know that WV is congruent to YZ. That's given. So WV, it's that side, is congruent to YZ. And I also know X is the midpoint of WY. So if X is the midpoint of WY, then it means, this is the line WY, then it means this side has to equal that side. So that means that WX is going to be congruent to YX. They're congruent because of definition of midpoint. So now I have my right angles. I have a leg that's congruent, the green ones. And I have my hypotenuse. Remember, hypotenuse is across. You can't have two legs. It has to be one hypotenuse, one leg. Since all of that is true, WVX is congruent to triangle YZX. Whoops. Because of hypotenuse leg. All right, that is it. So in this case, there would have been another way you could have proved it as well. If you see these are vertical angles, right? So you could use multiple ways to prove something. These are vertical angles, so you could have used angle, angle, side as well, right? So depending on the question, you could have used that. So angle, angle, side is also a good option for this one. All right, so this is it for this lesson.